heard Tina Fey say it 2 nights ago, so I'm gonna go on that. Yes. At a World Science event, no less. Yes?
Yes.
Wonderful. I've been instructed to read this introduction to you.
No, don't read it. Don't read it. Do not read it. You can say a couple of the parts.
Gregg Maryniak is co-founder, secretary, and director of the XPRIZE Foundation and chairman of the Energy and Space Tracks at Singularity University. He was CEO of the Space Studies Institute of Princeton, senior scientist at the Futron Corporation, and serves on the Directors Council of the Scripps Institute of Oceanography. His book, Fearless Experiments with Microcomputers, was released in 2017, and he's the only guy I know with a moon base named after him in a science fiction story. Welcome, Gregg.
Thank you, Mark. Well, I never met Sabe or heard him speak before today, but I'm in violent agreement with him that the thing we need to do to improve science results is accelerate time. We've got to have results quicker. That's the fundamental basis and problem. And the core reason why space science is limited is because of the scarcity of launch. And there's a word for people that believe that science is the principal reason for doing space flight, and that word is scientists. They're the only ones that believe it, by the way. If we want to be successful as scientists, we have to learn to surf off of the energy of much bigger, more powerful, and wealthy entities that are out there. Activities like military activity. When Pete Worden speaks to us later today, you should corral him sometime and ask him about how he perverted a completely good military mission to make it science, something called Clementine. Commercial activity, tourism, entertainment. We'll hit on all of these. We also really have to change the way we do business. So back in the mid-'80s, I had a very strong interaction on a space science thing. NASA for years had been trying to do a large scientific orbiter to fly around the moon in a polar orbit and do many different things. And that was the problem. There were so many different things that this orbiter cost about, in today's dollars, about $2 billion. It required an entire new start, a political impossibility. It was the Rolls-Royce of space probes. So my colleagues and I at the Space Studies Institute at Princeton decided to do the roller skate of space probes. This is not an accurate picture because this woman, this young lady here, has 2 roller skates. We weren't that ambitious. We just had one. We wanted to fly a gamma ray spectrometer and learn the chemical composition of the moon and look for ice. Because I also agree with Sabe that ice is one of the ultimate treasures of space. And we ultimately succeeded in a way we never expected. This is Dr. Ellen Binder, our chief scientist, and on the right side, Jim Burke from JPL, and the guy in the goofy blue suit is me. And this is a mock-up of Lunar Prospector, which was the roller skate of space probes. Because of Alan, who wanted magnetometers, we wound up putting more instruments than just the one that we started with. In a strange twist of fate, after we failed to raise the money, we designed this craft and we even had a launch lined up for it, but we couldn't raise the $25 million to build the spacecraft bus. But then NASA came along and was interested in having small missions fly. So this was the first Discovery class mission to be funded by NASA. It cost about $65 million as opposed to a couple $2 billion. And it found the ice at the poles of the moon, found hydrogen. Now, interestingly, at the same time frame, the fledgling International Space University was having its second session in Strasbourg, France in 1989, and we had our students there as one of the design projects tried to go down this path of small spacecraft for space science, and they refused to do it. They exactly mimicked the behavior of the real science community, and they fought with each other. And the only way that your payload would get to fly would be if my payload also gets to fly. So they wound up building something that cost about $4 billion and had a sub-satellite. It was very exciting, and we realized it was a good simulation when the grad students were exactly mimicking the real world. But the roller skate approach worked, and it was very risky. We were the only payload to be launched outside low Earth orbit by by this particular rocket, which is an Athena 2, made by Lockheed Martin. And NASA wrote 2 checks. They wrote one check for the Athena 2, and they wrote the other check for the rest of the program to build the spacecraft, and it was all carried out by Lockheed. Found the hydrogen, and subsequent missions by the US and India have verified there's probably at least tens of billions of tons of ice at both of the poles. But we're stuck with space with a chicken and egg problem. The problem is space flight's too expensive because we don't do much of it. And why don't we do too much of it? Because it's too expensive. So we have to break that paradigm if we're going to be successful in space. And the problem is there's only about 20 big commercial payloads per year, even today. And if you sum up all the little microsats, they still equal about 20 of the old-fashioned big ones. And that number hasn't changed at all in the last 15, 20 years. So we know if we'd fly many times a year, it would get cheaper. So people will say to us, well, what's the magic commercial payload of space that's going to require hundreds or thousands of flights? And the answer is, you are. Carbon-based, self-replicating payloads that you can make using common tools you have at home. People. And my partner in crime, Peter Diamandis, and I took a page from history from this. The fact that many of us came from disparate parts of the planet and are all here in New York is because this 25-year-old pilot in 1927 changed the way everybody thought about aviation overnight in pursuit of a prize, the Orteig Prize. And within a year of his flight, the number of pilots in America triples. The number of airplanes licensed in America quadruples. And within 18 months of his flight, the number of people buying tickets on commercial flights goes up 30 times, 30 times. So we put our own prize, the XPRIZE, originally X as a variable because we didn't have a sponsor. True story. And our prize was for the first private spacecraft that could carry 3 people to space altitude, 100 kilometers, 328,000 feet, and do that twice within 2 weeks. And thank you, Sarisha, for showing Spaceship One. We didn't have any idea who would win, nor did we particularly care. By the time we were done with our competition, we actually had 26 teams. This slide's a little bit before that. I think this only shows 24. We had 26 teams in 7 countries pursuing it. And as Sarisha pointed out, the winner was Burt Rutan's team at Scaled Composites, backed by Paul Allen. And there's Brian Binney standing on Spaceship One, and you can see the feather is deployed in that configuration, which automatically lines the ship up for reentry. And that's Brian touching down on Mojave. This is us giving the big check, which did not bounce despite some tests, to Bert and Paul, and that's at the St. Louis Science Center in St. Louis. Now we wound up being surprised by the huge amount of press. We could not afford to continue to count the press when we hit about 6 billion impressions. And we actually made it into some scientific journals, some that we had not, were not even aware of. This is one. Let's see, I need volume. Oh, well, you know what? We're not plugged in. Let's try again.
A world of unsurpassed comfort, yet many problems remain to be overcome. World hunger, disease, environmental destruction, our glaring lack of privately owned suborbital spacecraft. to report that we've made some progress on that last one. Because history was made yesterday when the creatively named Spaceship One flew 100 kilometers above the California desert before safely gliding back down to Earth, thus becoming the first privately owned vehicle to travel in space. Prior to landing, designer Burt Rutan got a little emotional.
It'll come down at the same angle and the same speed as a spaceship. So when you watch it descend from there, I want you to visualize like I do, and sometimes tears come to my eyes.
Tears in your eyes. If only you had something on your face that could absorb those tears. Some hair. Tear-absorbing feature. Rutan designed both the rocket ship and the plane that carried it into the sky. Though his greatest contribution was overseeing the construction, and every few days yelling, "Portholes, damn it, we need more portholes! I've got to..." Spaceship One and its plane took off at 6:45 a.m. After an hour's climb to 46,000 feet, the spaceship was launched into the stratosphere, where Captain Mike Melville proved it with 0 G's by unleashing M&Ms, which floated around the cabin. It was a fun idea, though he regretted his decision later to open up a bag of Big League Chew. Which I think would be a silly thing to do. And yet visually very amusing. Back on the ground, Melville was ecstatic over his experience.
Spectacular, it really was. The view from up there, I was so sad that Bert and Paul couldn't be with me.
Bert and Paul couldn't be with him. Yes, what a shame. The designer and chief investor of this untested experimental rocket opted not to come along on the maiden voyage. Spaceship One is now the favorite for the Ansari XPRIZE, a $10 million award for the first 3-seat repeated-use spacecraft. The prize was the brainchild of Dr. Peter Diamandis, whose name alone indicates he may be a James Bond villain.
So we hope that the Ansari XPRIZE will really kick off a renaissance of spaceflight, where we have our 27 teams now, but maybe a few years from now there will be double that number of teams flying. And people flying in space will be something that happens not a few times a year, but thousands of times per year.
Yes, that's what space needs, traffic. Yes.
Of course, that's exactly what spaceflight needs. That's precisely what it needs. That's the reason that we created this prize, to ignite an entire new industry, not based on just putting out telecommunications satellites or Earth-observing satellites, but to surf the wave of demand for humans, see how beautiful our planet is, and to have that view that Srisha showed us from low Earth orbit. And in the one piece of poetic justice that I've experienced in my life, hanging next to the Spirit of St. Louis that inspired our competition, is Spaceship One at the National Air and Space Museum. And we've just heard about the new test flights. Congratulations on the test flight this week, which is successful. We'll hear tomorrow from Dr. Erica Wagner of Blue Origin about the amazing work that they're doing on their suborbital craft. And not all these suborbital craft will carry people. This is the winner of the Northrop Grumman Lunar Lander Challenge, which was an XPRIZE funded by NASA as part of its centennial challenges, which are NASA's XPRIZes. NASA came to us and said, can we do XPRIZE type prizes? And if so, which ones should we do? This is Maston's vehicle called Zombie with an X, X-O-M-B-I-E. And here it is with there's a bent over person and a person in a cab there for scale. As far as I know, this has the record for the most rocket-powered flights back and forth. Last I checked, it was 227 flights. So again, you can get a much nicer ride from a vehicle like this or Spaceship Two than the kick in the butt you get when you launch on a sounding rocket, not to mention what happens when you come back down under parachute. First of all, the chute opens with a big shock, and then you tend to impact the desert floor. So these are pretty nice. As I think all of you know, we've teamed up with a small software company in the peninsula to do the Google Lunar XPRIZE, $20 million and another $10 million in other treats for the first private team that lands a vehicle on the moon, traverses half a kilometer, and shares the data and pictures with everybody in the world. And what we're trying to do is expand the realm of commercial activity by a factor of 10. Right now, the limit of commercial activity in our two-world system is 10% of the way to the moon, geostationary orbit. And so this would be an extremely important thing for science if we can get for less than $100 million material delivered to the moon. But where else might we surf? Well, lasers are very interesting. Jerry O'Neill, my mentor at Princeton, told me after hearing me lecture once, he gave me some sage advice, which I impart to you. He said, always use a laser pointer when you lecture. I said, why, Jerry? He said, because that way you could be coherent and incoherent simultaneously. So the cool thing about lasers is that we can send a lot of information without it spreading out. And for deep space exploration, the next bottleneck after access to launch, which is a huge bottleneck, is how do you get your data back? And it's proving to be very challenging to get time on things like the Deep Space Network to have bandwidth back. So coherent stuff, when Pete Worden talks about Starshot, that's one of the really interesting challenges that they face. How do you get stuff back from approximately 4.5 light years with small artifacts? But there's some pretty cool laser comm work going underway, so that's something to surf. Another thing to surf is these potential constellations, commercial constellations in space. Now, constellations, this is teledesic from 20 years ago, didn't happen, but if they do happen, and I think this time they might, it could be pretty exciting. This is not a new idea. This is a little bit like 3D printing, you know, an overnight success after 50 years. This is, as far as I know, one of the first constellations. These satellites that are in the factory here in the mid-1960s were defense communications satellites, and 8 of them were launched by one vehicle. But in February of this year, Israel, the Indian Space Research Organization, deposited about 100 microsatellites on one flight. In fact, I had to cut this video down because it's boring to watch 100 satellites. And that's OneWeb, the new one. So what if constellations and small sats change the launch paradigm? If we start really doing lots of small things, then we might invoke some of these serial launch concepts like laser launching or using RF energy beamed to reduce the cost of launch by a factor of 1,000, not a few percent. The most important thing we can do is to change the style of spaceflight. In fact, back in 1979, I interviewed Professor Freeman Dyson from the Institute for Advanced Study, and he was working on laser launching and solar sailing and and Orion, famously, Project Orion. And I said, Professor Dyson, what technology is it going to take for regular folks like us to get to fly in space? You could say the same thing for space science payloads. He said, we don't need any new technology. What we need is to change the style of space operations. And it took me about 20 years to get what he meant by that. He's exactly right. That's the crux of the problem. You've got to have players that act very, very differently, especially as it pertains to risk. And that's what this whole new space world that XPRIZE and our colleagues are involved in. It changes the risk factor, and that is going to enable us to do a lot more science in a lot less time. So what we must do fundamentally is increase the launch rate dramatically from what we do now. And PRIZE has changed what everybody knew about spaceflight, most importantly, the style. Thank you very much.
Thank you very much for the wonderful talk. So I have a provocative question. So how can XPRIZE and say Virgin Galactic or Blue Horizons work together to have a prize for a science payload, what they can carry to space? Is there any possibility for that? Can we have a prize for detecting gravitational waves in space? Can we have a prize of detecting gravitational waves from the origins?
So the short answer is If you look at history, sure. One of the first big government prizes is the Longitude Act. When the British government decided it was sick and tired of killing 1,000 sailors at a crack because they couldn't figure out the longitude, so they put out a prize for the first method of telling time that was accurate enough to calculate longitude. The bad news was they put scientists in charge of it, and they were fixated on using the motion of the Jovian moons for timekeeping, and they refused to give John Harrison, who actually invented jeweled bearings and made precision timepieces possible. So, yes, good idea. Don't necessarily put scientists in charge of it. Somebody else.
Do you have any sort of lessons learned from the Ansari XPRIZE, given that it's been nearly 13 years since the prize was won and we don't have that explosion of suborbital spaceflight yet?
Yes, but too long an answer to, and alcohol has to be involved. So save it for the let's save that discussion for the reception today. But there are a lot of things. As Sarisha pointed out, it's harder than you think. Elon Musk asked us years when he told us he was thinking about a launch company, and Peter and I had started one, lost a shirt at it, not this shirt. And we said, look, Elon, however long you think it'll take, it'll be 3 times as long. However much you think it'll cost, it'll be 3 times as much. And for God's sakes, whatever you do, don't make your own engines. Well, fortunately, he didn't listen to us, but Peter tells me, I was not privy to this part of the conversation. Peter tells me Elon called him one time and said, Peter, you lied to me. I said, what do you mean? Elon, I never lied to you. He said it was 5 times, which I think is probably a true story, but I'm not sure. I see Sarisha's hand up, so.
I just wanted your opinion on what areas, science especially, could use a prize incentive to get more researchers into that area. Like, are there any areas you see as giving us, a great deal of benefit, but no one's going in to that area?
So, very interesting question. So, I'll tell you one that we're thinking about. We have a lot of things now about reducing carbon, energy-related prizes and such. We had an idea for a prize. Three other folks and I won an internal prize at XPRIZE for coming up with a prize idea that we called forbidden energy. And the idea was that low-energy nuclear reactions there seems to be something going on that doesn't violate physics, but we don't really understand it. But you can't talk about that stuff in polite company since the Pons-Fleischmann cold fusion debacle. So we said, what about a prize in that area that would cause, because what prizes do is they tend to legitimatize an area of work that's kind of fringy, like this stuff was. It's hard to find backers, your spouse is mad at you all the time, it's not good. But once there's a legitimate competition, some of that stuff gets better. So that's an example of one, but there are lots. They're just limited by creativity and our bandwidth. But I'm happy to talk to people that want to do prizes, and we're getting better at it. And there's a very definite technology to it. So thank you very much.
Thank you.